But the route inspection algorithm is a way of finding a route through a network that travels along every edge at least once, so we can go over them more than once now, and returns back to its starting point. You can kind of see why this is called Chinese postman, in that if you're a postman, you need to go along every road to deliver your letters to houses. You can go along them more than once, but you want to do that in the shortest possible. So, in an Eulerian graph, a trail which visits all the edges must start and end in the same place. That's like the example one. Whereas in a semi-Eulerian graph, so that was like the third one, you have to start and end at different nodes, and they have to be the two odd nodes in your semi-Eulerian graph. If you want some real life applications, delivery routes. So trying to go down every street to deliver to every house as fast as possible way. Gridding roads, ensure every road is gridded again in short. So these are the steps. I'll talk you briefly through them, but they'll make more sense once we do an example. So the idea is you start off with a graph. With some nodes and some axes. First thing for you to do is to identify all of the odd nodes in that graph. Okay. If you have no odd nodes, you'll be fine. It's Eulerian, and you could just start where you wanted and just draw along. If you've only got two odd nodes, there's not much to do because you could just start and end and start at one of them, end at the other one. But usually there will be more than two odd nodes. Okay, so first off is to identify all the odd nodes. What we want to be able to do is to essentially draw our graph without taking apples off the paper. This is equivalent to you being able to go along all of the arcs of the graph in the shortest possible way. So what we're going to try and do is work out which are the best routes to repeat, because we're going to have to go back on ourselves at some point. And to do that, we're going to consider the possible pairings of the odd vertices. Okay, essentially, we're going to turn this graph into an Eulerian graph by matching up the odd vertices and turning them into even vertices. Okay? We're obviously going to pick the smallest ones to repeat, because that will give us the smallest possible distance or whatever it is. And then you might have to find a route that works. This will make more sense when we go through an example. One thing to note is that just because two nodes are linked directly to each other, it doesn't necessarily mean that that is the shortest route between them. Sometimes you might have to go in a roundabout way to actually get the shortest route through a network, which is what this is. So the example that we've got here is from C to D. So the direct arc is 5, but this is not the shortest way to get from C to D, because if you go via E, that's just 2, add 1, that's just 3. You've just got to be really careful when you are checking through your networks when you do. So this is the example that you have in your, and so this is the graph that we're going to be doing this route inspection algorithm. The question says, for the following network, find the minimum route which traverses every arc and starts and ends at vertex A. So the length of your route and the arcs that need to be repeated. So actually, it doesn't matter where we're starting and ending. I'm starting and ending at the same time. The first thing to do is to identify the odd nodes in this network. So they do this via a valency table, or I tend to just label up on the actual vertex what the order is. But remember, the order is how many lines are coming out of that vertex bit. If you want to do a table, vertex A has valency or order 3, 3 lines coming out of that. B is also 3. C is also 3. D is 4. That's an even node that we've got there. E is 2, that one's even. F is 3, and G is order 2. So we have identified that in this network we have 4 odd nodes. It's not Eulerian or semi-Eulerian yet. Okay. So the odd nodes that we need to look at are A, B, C, and F. what we're going to do is find the best way to link these nodes up to each other to ensure that we've got the shortest route through this network. So we've got to consider all of the possible pairings that we can have, and there'll be 3 pairings for us to consider. Okay. So we could consider AB, joining up AB, and we could consider joining up C and F. We could also consider joining up A and C and B and F, which we'll do in a minute, and we could do A and F and B and C as well. There are 3 possible options. So what we do with the route inspection algorithm is we take these one at a time. So I'm going to look at joining up A and B first, and I want to look at the shortest way of doing this, which may or may not be the direct route. In this case, it is the direct route for A and B. So the shortest, the direct route is 48. Your other options would be kind of going via C. Well, that's 117. It's not that one. Or going via D, which is 92. Obviously, it's neither of those, but you have to check them. So the shortest route from A to B is just AB. From C to F, so C is here and F is down here. It's a little bit more complicated. So you're asking yourself, what's the best way to get from C to F? So there are a few different options. You could go via D, so along this 28, and then along this 132 here. So that would give you 160. You could go via E, but that would be longer than D to F, so I'm not going to do that one. You could maybe go in a roundabout way via G and B, but that's going to be longer as well. So the shortest one is from C to D to F. Okay, so that's what I would like you to write down, is that we're considering A, B, and C, F. We've got shortest route from A to B is 48, shortest route from C to F is 160, for a total of 208. It's also worth jotting down that you're going via D from your C to F.
They've just said A, B, C, and F. They can just take a random pair, can't they?
We're going to consider all 3 of them. So this is just doing the first.
Okay.
Everybody okay with what we've done so far? Now we'll consider the next pairing. So next combination we're going to do is AC and BF. So we're going to do the same thing for this one and try to find which is the shortest total out of these. So from A to C, there is a direct link from A to C, which is 117. Think about, is that the shortest one? Well, it will be. You could go via B, but 48 add 55 add 85, it's going to be longer. You could go via D, it's very close going via D. So you've got 92 plus 28, but that will give you 120 rather than 117. So 117 is the shortest one from A to C. From B to F, the direct one is 63. That one's going to be the shortest because you're going to have to go all around the houses to get from any of the other ones. We've got 117 and 63 for those ones, which do happen to be the direct ones, which is quite a lot shorter than the first one, gives us a total of 180. Last combination of pairings to consider is A, F, and B, C. So looking at A to F, so I'm thinking the most direct one is looking like via B. So A to B to F will be 111. It's worth checking any other ones, but you've got to go 117 up to C already. It's obviously not that one. You've got to go 92 to D and then further on. So it's not going to be that one. So it's going to be 111 from A to B to F. From B to C, considering your options for this one, so you could go via A, so you could go 48, add your 117, which would give us 165. You could go via G, so you go B to G to C, so that one will be 140. That's the shortest so far. Or you could go via F, but that's going to be way longer because you've got to go all the way around. So via G is your best option for B to C. And that's the biggest out of the 3, that's 251. But you do need all of those on. So they do need to be correct for you to get all the answers. Okay, so you've got to consider a lot of different options and be really careful with it. Out of these 3, we're going to choose the middle one. Okay, so the middle is the shortest option that we have, A, C, and B, F. These were the direct ones this time. So what this means is that A to C and B to F are the arcs that we are going to review. Remember, in the question, it says state the arcs that need to be repeated. So A to C needs to be repeated and B to F needs to be repeated. If we had gone via another node, so for example, if I'd done, I don't know, a good example here, but if we'd gone like BAC, for example, between B and C, you would need to state that you're repeating arcs BA and AC. You're not inventing new roads, you're not doing new roads between ones, you're going along pre-existing ones. So if you've gone via another node, you need to state that you've gone over two arcs or something. Okay, so repeating AC and BF in this case. It also asks for the total weight or total length of your route. You usually don't need to add all of these up yourself. Notice it tells you what your total weight is in the question, tells you it's 802. So you've just got to add on that extra 180 to this to get the overall total weight of your network. Okay. There should be 982 for the total weight. Like it said, now the graph is Eulerian. Technically, you could start and start at any node and end up back at that node, but specifically this asks you to start at A and end up back at A. Okay, so they've put dotted lines on for the arcs that we're going to repeat. Just so you can see now, these are all order 4. A is order 4, B is order 4, C is order 4, F is order 4. It does ask for a minimum route. The question says, find the minimum route which traverses every arc and starts at ends of vertex A. There are loads of different answers that you could give for this one. As long as you just kind of go along every arc, you'll get there. So an example one here, they've just listed all the nodes that they've gone through. That's what they would want you to do. But realistically, you could just kind of go in any direction and it'll work. So they've gone A to B to F, up to E, up to D, up to C, G, then back up to B, and all that kind of stuff. I think the easiest way to do it is either to draw it yourself as you go along or highlight along it or something like that. Jot down the nodes that you go through as you go along, but there are loads of different answers that you could give for them. If you want to jot that one down as an example. Are there any questions for that? Like I've said before, and I'll say it again, you've got to be really, really careful with these. Even if you end up with the correct answer, you can still lose marks on these questions if you've missed off one of the shorter ones of the other ones. Even if you'd picked out the middle bit, if I'd have got this 208 wrong or this 251 wrong, still would have lost a few marks on this. I'd like you to have a go at the ones underneath. Identifying your odd nodes, you should get 4 odd nodes here. You get A, B, D, and F. They're all order 3. Consider your pairings of these. So A, B, and D, F first. So A, B, your shortest from A to B is via E. So it's close via F, but you get 33 and 32. So shortest is via E. Check all going a long way around, so check going by a G, see if that's shorter. But this is 21 there, so it's not. DF, there is a direct one, which is 9, which is the shortest one. So that gives you 41. A, D, and B, F, you also get 41. So A to D, the shortest one, is the direct one, although it's close via F. That gives you 27, that's 26. And B, F, shortest one is 15. It would be way longer to go around that. A, F plus B, D, you get 42 for. So A to F, direct one, is the shortest one. And B to D, we're going to go via F, gives you 24 and gives you 42. Those have to all be correct to get full marks. Because those two are the same, you can choose either the top one or the middle one. It doesn't actually matter as long as you're clear which one you've chosen. So if you choose the top one, you're repeating A, E, and EB or BE, and you're repeating DF as well. Make sure you state those 3 arcs that you are repeating. It tells you on the screen the total weight of the network is 258. So add on that 41 gives you a total of 299 plus. Now it also asked you for a route. So let's look together. So we're starting at A, aren't we? So You can basically choose whatever direction to go in you like. It doesn't matter and it'll end up working out. So do it one at a time. So at A, I'm going to write down A. I can go in any direction I want. So I'm going to go to E. And it's easier if you can draw along to see where you've been already, which I can't. So I'm going to go to E. I'm going to go up to C. I'm going to go along to G and I might go back to C then as well. So D, C like that. So I've done this top bit here. So I'm back at C at the moment. I've already gone this way, so I can't go back along it. So I'm going to go down now to D. I'm going to go to F and back along those ones. So D, F, T. Yeah, because this is one of the ones that I'm repeating. Not only along the ones that I'm repeating, I can do that. I'm going to go back up to A because I don't have an option there. I'm now going to go down to F. I'm just kind of randomly choosing, it doesn't really matter. I'm going up to B now, which I haven't been there before. Let's go up to G.
Oh my god.
Down to E. Haven't done this bit yet, so I'm going to go to B and back. B to E, and then I've got one more of these left to go to. So literally writing down the list of things that I've letters. There'll be loads of different options you can have. Basically, you can't really go wrong with it. Just